Okay, on problem 11 from page 3 of the review packet. To rent office space for your business, you must pay a one-time fee of $1,000 and pay rent of $800 per month. A. We want to write a linear model that represents the total cost of renting office space as a function of the number of months you will rent. Well, we have the one-time and we have the recurring, and so the one-time is going to be the y-intercept. The recurring is going to be the slope, and so we very simply have this equation: 800 times the number of months we rent plus the $1,000 one-time fee. So that's for part A. For part B, find the total cost of renting office space for 1 year. Well, for 1 year, X would be 12. The number of months would be 12, and we simply have to use our calculator. And we would need 800 times 12, and that is equal to 9,600 plus 1,000, and that would cost us $10,600. All right, point C, or question C. A different building has office space for rent that does not require a one-time fee, but you must pay a rent of $1,000 a month. If you have $15,000, at which building can you rent office space for the greatest amount of time? All right, so what we're going to do simply, he says simply, what we're going to do is, we have two different equations. Let's write our equation for the second office building. In that one, there is no one-time fee, but the rent is $1,000 a month. So our second equation, or the equation that gives us the total amount we will spend to rent the second office, so we'll call this first and this one second, is just 1,000x. Now, what we're going to do is set each of these equal to 15,000 and see which one gives us the larger x. So for the first one, 15,000 is equal to 800x plus 1,000. We want the y value to be 15,000. We're going to subtract 1,000, subtract 1,000, and we get 14,000 is equal to 800x. If we use our calculator, we're going to divide both sides by 800, divide both sides by 800, and we will get x is equal to 14,000 divided by 800 gives us 17.5 months. So 17.5 months. With the other, our equation is 1,000x. We want that to equal 15,000. We're simply going to divide both sides by 1,000, and we get x is equal to 15. So the first, we can rent for 17.5 months, and this one rent for 15 months. So we can rent longer with the first building than we can with the second building. All right, so that's a real-world equation or real-world problem that we can analyze and solve using the techniques of using linear equations, using the slopes and y-intercepts, and manipulating them in different ways. We'll go on to one more problem on this third page. With problem 12, The table shows the distance covered by a spaceship in outer space. First of all, can the situation be modeled by a linear equation? Explain. So if we look at our differences, the x values, or time, is going up by 3 seconds in each case. That's a good sign. The y values are going up by 15 miles in each case. So 15 miles. And so what is our slope? Our slope is simply the change in y over the change in x, or 5 miles per second. Notice the units for the y are miles, the units for the x are seconds, so the slope is 5 miles per second. So we would say, can it be modeled? Yes. Slopes between every two pair of points is the same. Okay. So now let's go ahead and write this as a linear model that represents the distance traveled as a function of time. So the next thing, once we have a slope, we're going to write this in point slope form. And y minus, we'll pick the first point, y minus 5 is equal to 5 times x minus 1. Multiplying it out, y minus 5 is equal to 5x minus 5 plus 5 plus 5, and we would get the equation y is equal to 5x. Now that doesn't appear to have a y-intercept, and we are going up by 3 in the time, up by 15, so we really are going up by 5 miles every second, and so we're not starting from any point, and so it is reasonable that we should just have an equation that is y is equal to 5x. So we travel 5 miles, we travel 5 miles for every second of the journey. And so if we can test this out by saying, well, if we travel 10 seconds, we should have traveled 5 times 10, or 50, and you can see that that is correct. So plugging in any of those numbers above into our equation will give us the distance traveled, and so we have succeeded. All right, so that's going to do it for this particular, for the third page of the review packet.